Here's the cleaning and the setup of the Babington burner. To clean it out, simply remove the burner assembly, nozzle assembly from the tube, and then I have everything loose so that the heat tube can also be removed easily. Doesn't really have to be latched down. And then all you need is something to clean the inner pipe out with. I keep the pipe handy, and you can just run it up and down inside the tube and not get any soot out of it. Every 8 hours or so of running it, sometimes more, sometimes up to 20 hours, it needs a good cleaning. And that's about all there is to it. Reinsert the tube. Reinsert the nozzle assembly. And it's ready to go again. One of the other processes that helps keep the heater running well is to clean the nozzle. It will get some soot built up on it. If it gets too thick, it can close off the orifices that allow the oil to come out of the end. Typically the oil runs out enough that it doesn't get clogged, but just to keep it clean is kind of nice. Keep a rag handy, and it's fairly easy to do. One of the keys to making this heater run well is allowing the preheater tube to heat up well and to get the oil up to temperature. Mine is currently set at about 205 degrees, and the airflow is on a needle valve. You can use any style needle valve really to flow the air, or you can regulate the air with a actual regulator. About 30 or 40 psi seems to work quite well. Currently, though, the needle valve works pretty well. I just tune it in to whatever makes the heater run well. One of the keys to making this unit run well is getting enough heat into the preheater, allowing the nozzle to preheat a little bit. To speed things along, it'll save some time to actually throw some flame onto the nozzle and the needle valve assembly. Keep in mind there is some rubber gaskets and O-rings in here. You may want to take that apart when you first get it to inspect them, see what kind of quality or shape they're in. But you don't want to overheat this, or you can melt those down. But a little bit of heat in the nozzle speeds up the process. I usually hold the torch there for approximately 20 seconds or so. That allows the heater to get going well. So let's turn the air on, and we'll turn the oil on. You'll hear the oil start to atomize. You'll have to play with the amount of needle valve that you need to get the right flow. Currently my damper is open quite wide. I probably need to neck that down to allow the burner to really get running right. The initial burn is not super clean. There is some drippage that goes beyond the nozzle tip, and you will see some smoke coming out of the chimney until the tube comes up to temperature and until you get it tuned right. You can mark your needle valve or take note of where it runs the best for startup and where it runs the best when it's all heated up and preheated. You can get a fair amount of heat out of this unit once it's up and running. I like to run it as clean as possible, so I usually neck down the needle valve until it's lean enough to where I get no emissions or no smoke from the chimney. And it's up and running. Similar to a car engine, you'll find that when you add more oil, you also need to add more air to create the correct fuel-air mixture. The ratio needs to be close. And too much air results in a lean run. You get kind of sputtery. Down, you put it right out. Too little air allows oil to drip right past the nozzle and not atomize properly. So it takes just a little bit to find that balance and make it run proper. As a side note, I currently have 110 volt power going into the snap switch. And I run this line right here, this terminal, that's an exposed terminal, but I use the neutral line of the AC power to put the power to my heater cartridge. So with that, it's safer to touch. I still won't want to be standing in a puddle and touching it, but it is a little safer to touch than it was the black hot wire. The common wire is more suitable to the switch for this application since it is exposed. As you may have already discovered with the Babington style heaters, there is some oil that drips by the nozzle. This style nozzle limits that to a very minimal amount. I still keep the heater on a slight decline away from the nozzle, so any oil that does disperse out of the nozzle onto the heat tube will run down to the end of the heat tube. The heat tube is red hot when it's up to temperature. That oil burns off rather quickly, and it runs very clean once everything's up to temperature. But that is one critical thing when you set this up, to not have the heater sloping back the other direction. It's going to cause oil to leak out of the end and smoke off the end of the heater or make a puddle. Another side note that I'll make mention of is that I keep my preheater block close to my barrel. This puts heat from the heater back into the heater block. This allows me to use a lot less electricity because the preheating of the oil is done more by the heater once everything's up and running than it is by the power to the heater cartridge. If you get this block too close though to your heat source, you will have a problem with boiling the oil. And that's not a good thing either, because it'll cause the oil to collect and build up on the inside of this aluminum cartridge. Easy fix though, you can always run a drill back through there and clean it back out. It really is not a huge issue. And the hotter the oil is, the better the unit runs. As you can see, this heater is putting out lots of heat right now, lots of flame. I got it running a little bit rich to get everything rolling, but putting out lots of heat right now. Very effective for heating the barn. And I've also put this is a shot of the heater running where it is leaned down a bit. I'm running more efficiently right now. I'm not putting quite so much gas into the chamber. And still putting out plenty of heat. It just saves a little more oil once the barn comes up to temperature.